So now, let's proceed to illustration 1.10. So a body is dropped from a height of 80 meters. Find the time taken by the body to reach the ground and velocity on reaching the ground. So we're going to approach this one. So a body is dropped from a height of 80 meters. So let's say on the top of a building, which is 80 meters high. Our body is dropped. Okay. So when we say drop, this is its initial velocity will be equal to 0. Okay. Find the time taken by the body to reach the ground. That's the first question. So that is from when you drop the body, so there's a time interval reaching the ground. So let's say that is capital T. Okay. And the velocity on reaching the ground. So before it comes to rest, so final velocity will be unknown. So time. So recall the formula for time, pre-fall. So that is time will be equal to square root of what? Twice the maximum height or the height over acceleration due to gravity. So this is equivalent to square root of twice the height 80. So 2 times 80 over 9.81. So time taken will be equal to what? 4.04. So 4.04 seconds. So that is the time taken. Let's say solving for final velocity. Sorry, this is a question mark. This is unknown based on the given. Okay, so final velocity. Solving for final velocity. So direction of the final velocity is downward. So that is final velocity will be equal to square root of 2 acceleration due to gravity and the height. So this will be equal to square root of 2 multiplied by 9.81, then multiplied by height of 80. So the final velocity will be equal to 39.62 meter per second, and its direction is downward. Okay, so another solution. So if you don't want to use the formula, shortcut formula, okay, you can use the three main formulas. Let's say alternative solution. So solving for the time, okay, using given displacement. So let's say S will be equal to initial velocity multiplied by time minus 1/2 acceleration due to gravity squared. Okay. Now S is what? displacement. So the initial position is above the ground. So the final position is below. So this has a value of negative 80. Okay, so initial velocity is 0. So 0 multiplied by time is 0. So that is 0. Okay, and minus 1/2 acceleration due to gravity multiplied by time squared. Okay, now dividing both sides by -1, so the sign negative will be eliminated. Simplifying, this will be time will be equal to square root of 2 multiplied by 80 all over 9.81. So that is 160 divided by 9.81, then square root, so that is time will be equal to same 4.04 seconds. Okay, and the other solving for the final velocity, you can use the formula final velocity is equivalent to initial minus acceleration due to gravity and displacement. I mean, this I mean time, we given time. So final velocity for reaching the ground is equivalent to, this is 0 minus 9.81 multiplied by 4.04. Okay, so the final velocity will be equal to, so 0 negative, so that is negative 9.81 times 4.04, that would be 39.63 meter per second. Again, negative indicates its direction, which is downward, so this is also similar. So you can choose whether to use the original 3 formula or shortcut one given when a ball is dropped or a body is dropped or a particle is dropped from a height. Okay. So a ball is thrown up, is caught by the thrower after 4 seconds. So how high does it go, and with what velocity was it thrown? So a ball is thrown up. So let's say on the ground level. Okay. So a ball is thrown vertically upward. Okay. Then reaching its highest point, then starts to go down again, and the thrower catches it with a time of 4 seconds. So how high does it go? So that is the maximum height. This is unknown. Okay, and what was its initial velocity? That is the second unknown. So first is the height, and second is its velocity. Okay, now let's see. Given is simply total time interval, that is from going up until the thrower catches the ball. Total time of interval is 4 seconds. So we have a formula of time. Total time taken is equivalent to twice the initial velocity all over acceleration due to gravity. So based on this formula, you can have time as 4, and this is twice the initial velocity, and acceleration due to gravity is 9.81. So simplifying this, you can solve for initial velocity. Initial velocity will be equal to 19.62 meter per seconds. Okay, so that is the initial velocity. Now, the maximum height using the formula. So solving for the maximum height, you have the formula of height is equivalent to initial velocity squared over the formula G. Let's see. We get there is A to G. So 2G. So this becomes initial velocity 19.62. So 19.62 then squared over 2y 9.81. So the maximum height will be equal to 8. Let's calculate. So 19.62 squared divided by 2 and divided by 9.81. So that is 19.62 meter per second. Meter. Sorry. 19.62 meters only. Sorry. And meters. That is the maximum height. Okay. So illustration 1.12. From the top of the building, 160 meters high, a ball is dropped at, and at the same time a stone is projected vertically upward from the ground with a velocity of 40 meters per second. And when and where the ball and the stone will meet. So in this problem, a ball is dropped from the top of a building, which is how many meters? 160 meters high. Okay. Let's say that ball point A is dropped, and at the same instant a stone is thrown vertically upward. So let's say point A is the ball and point B is the stone. So initial velocity of the ball is 0 because the ball is simply dropped from the top of the building, and the stone is thrown vertically upward with initial velocity of 40 meters per second. Okay, so the question is find when, so when is time, and where the ball and the stone will meet. So when will the ball and the stone meet? So let's say while the ball is going up, while the ball is going down, and the same instant the stone is going up. When will they meet? Possible here. So let's say the height that the stone reached is x. Okay, the x distance. So the ball will have a distance traveled of, I mean, 160 minus x. Okay, so time limit is the same, so that is time. Okay, so the question is when and where, so time and uh, above ground level, so x. So I'm going to solve this one. Let's see, for the ball. So let's say for A, for the ball. So using displacement, S is equivalent to initial velocity multiplied by time minus 1/2 gt squared. Okay, so S. Uh, S is initial position of the ball. So this is traveled below. So this has a value of negative 160 minus x. Use sign convention. Then this is equivalent to initial velocity is 0 multiplied by time, so that is 0. Okay, then minus 1/2 gt squared. Okay, so let's say this will be equation number 1. Okay, now let us consider the stone. So for the stone, let's say that is simply point B. So using similar formula, so initial position is on the ground, and the struggle is above, so that is positive x. So x is s equals initial velocity of the stone is 40 multiplied by time, then minus 1/2 gt squared. This will be equation 2. Now I will add equation 1 and equation 2. So I add equation 1 and equation 2. So equation 1 is this one. So negative 160 positive x. So x minus 160. Okay, I just distributed the negative sign. So negative 160, then negative negative will become positive. So positive x minus 160 equals 0 minus 1/2 gt squared. Then equation 2 is x equals 40t minus 1/2 gt squared. Oops, sorry. Should have done, this is negative 160. I said add equation 1 and equation 2. So we can say that on equation 1, since this is negative and that is negative, you can divide both sides by negative 1. So this can be eliminated already. So probably this one appears and this one will become positive. So in this equation, you can divide both sides by negative 1. So this is 160 minus x equals positive 1/2 gt squared. So this should have been the equation 1. Okay. So and okay. Now set add 1 and equation 2. So 160 is constant. So you simply add. So 160 no constant. So that is simply 160. Then negative x plus x is 0. So that is equivalent to 0 plus 40t. So this becomes 40t. Then similar, so this is equivalent to 0. So therefore time is equivalent to 160 divided by 40, 4 seconds. Okay. Now, where would they meet? Okay. So I could say, this is good. Okay, I forgot. So I could substitute the value of time to equation. Equation 1 or 2? I should say 1 here. Okay, so I would say substituting the value of time to equation 1. Okay, so equation 1, 160 minus x is equivalent to 1/2. Acceleration due to gravity is 9.81. Then t squared, that is 4, then squared. So simplifying this given, and I will give you 160 minus x is equivalent to 4 squared multiplied by 9.81 divided by 2, 78.48. Then they would meet at 21.52 meters above ground based on the figure. Okay, so they will meet at 81.52 meters above ground after 4 seconds when the ball is dropped, and at the same time the stone is thrown upward. So next problem will be a balloon is at a height of 40 meters. Okay, and is ascending with the velocity of 10 meters per second. So a bag of 5 kilogram weight is dropped from it. When will the body reach the surface of the earth? So a balloon is ascending, so it is going up. But then a bag of 5 kilogram weight. So let's say this is the ground and this is the balloon. Okay, so a bag is dropped 5 kilogram drop. So therefore we can say that the initial velocity of the bag will be equal to the initial velocity of the balloon, which is equivalent to 10 meters per second. So it is going down. So the question is when? When represents time. So when will the body reaches the ground? So that is question is time. So height is given. Height is given 40 meters. Okay. Height. So we'll be using displacement. So let's say S is equivalent to initial velocity multiplied by time. Then minus 1 half gt squared. Okay. So initial position is above ground. So therefore S is negative 40. It's below the initial position. Will be equal to initial velocity of 10, then time minus 1 half acceleration of 1.81 t squared. Then simplifying the equation and arranging them, so this becomes negative 4.905. Then so 4.905 so t squared minus 10t minus 40 will be equal to 0. So this equation represents second degree polynomial, so that is in quadratic equation form. So you can use quadratic formulas solving for time. So reminder, quadratic formula is written as x is equivalent to negative of b plus or minus square root of b squared minus 4ac over 2a. Okay, so solving for time, time is equivalent to negative of b, negative of b. So that is negative of b, b is negative 10 plus or minus square root of, so that is b squared, negative 10 squared minus 4, a is 4.905, so 4.905, and c is negative 40 over 2 4.905. So that is 2A below or the denominator. Now simplifying, this will be equal to negative of negative 10 will be positive 10 plus or minus square root of this one is 29.75 over 9.81. So solving for the time, we have two values here. So that will give you, let's say, time 1, take positive, so plus. So that is 10 plus 29.75 all over 9.81. So this also value of time 1 will be equal to 4.05 seconds. Now for time 2, take the negative sign here, so that is 10 minus 29.75 over 1.81. So T2 will be equal to 10 minus negative 19, so this is negative 2.01 seconds. Now, we have a negative time, so there's no such thing as negative time. So the final answer will be positive time. Okay? So this is neglected. Neglected. Okay? There's no such thing as negative time. Okay? So the answer is the body will reach the surface after 4.05 seconds.